A colossal iceberg, more giant than a city, broke away from Antarctica in mid-2021. It's so big that it's 40 times bigger than Paris and 73 times the size of Manhattan. Imagine that you come out of your small holiday shack on the coast of South Africa, near the town of Port Elizabeth. You have a cup of tea in your hand as you've just woken up. You stand near the edge of your lookout, the vast Indian Ocean before you. Something catches your eye. To the right, there is something so monumental, you can't comprehend it. It's a giant slab of ice, 300 feet high, and stretching away many miles, as far as the eye can see. It rolls slowly, but relentlessly on, heading out into the deep sea. If it goes far enough, it could reach the western coast of Australia. Playing in front of it are a pod of dolphins, like they sometimes do off the bow of a ship. Yet they're just specks compared to the mammoth size. You're so shocked that you drop your cup. Your eyes are as big as saucers. It's like something out of a science fiction movie. Are you dreaming? Are you seeing things? Nope. It's A76. It's real, and it's currently on the move. What could happen to it is anyone's guess. Well, scientists have a few theories, but let's get a grasp of its size first. The iceberg is 110 miles long and 16 miles wide. It's basically the shape of a gigantic finger. If you were standing at the coast of Dover, looking across the English Channel toward France, the iceberg would be almost as wide. The channel is 21 miles across at its narrowest. That means approximately 2/3 of that distance would be filled with the iceberg. That's if it were drifting, finger pointing down, so to speak. If it were facing the other way, it could still enter the English Channel, but as it got closer to the narrowest points, it would smash into the coasts of both England and France. It would go up over land. It would slide over the green fields of England, the white ice bold against the rich green. It would cruise past the vineyards of France. It was temporarily lowering the temperature of everything around it. Those grapes would be like jelly crystals. It would skim right over highways, cars stopping to observe this colossal thing like a visitor from another galaxy. You could pluck chunks off it for your drink as it sailed past. Failing that, you could scale it and go ice climbing, right on the outskirts of London. It would certainly be handy in the summer. But let's get back to what actually happened, and what scientists think will happen to it. As of the beginning of 2022, A76 is the world's most giant floating iceberg. It was calved from the Filchner Ronne ice shelf in Antarctica in the middle of May 2021. Ice calving, also known as glacier calving, is the breaking up of ice chunks from the edge of a glacier. It then pulls away from the ice mass into a separate entity. If you were nearby, you would hear a lot of cracking and a massive booming sound. Blocks of ice up to 200 feet would break free and crash into the water. It would cause huge waves. Not even adventurous surfers would want to tackle those breakers. Ice calving is a natural event. The area where A76 broke off has seen little change in recent decades. There have been even larger chunks of ice than A76, but this one is currently the largest in the world. Scientists at the British Antarctic Survey spotted it. There are satellite images of it breaking free, as captured by the European Space Agency's Sentinel-1A satellite. The size at the calving was an estimated 1,670 square miles. Right now, it's in the Weddell Sea around Antarctica. The Weddell Sea is part of the Southern Ocean. It was named after the Scottish sailor James Weddell, who entered the area in 1823. Scientists have deemed the Weddell Sea to have the clearest water of any sea. Imagine peering down into its depths from a boat. What a fantastic view it must be. The area is full of whales and seals. As you look down, you may see killer whales, humpback whales, minke whales, leopard seals, and crab-eater seals. And if you look towards land, you'll likely see a colony of Adelie penguins. They're the dominant penguin species in this area because they adapt to the harsh environment. In fact, this is the only location in the world they live. What an incredible array of wildlife to observe, all from the comfort of the ship's deck, while you drink another cup of hot tea. It gets pretty cold in these parts. To get an idea of what could happen to A76, scientists refer to other data, such as the even more enormous iceberg called A68. It was calved from the ice shelf known as Larsen C off Antarctica in 2017. While it may be exciting, though a little daunting, to think of it also sailing up the English Channel, A68 floated out to warmer seas and, by early 2021, had all but dissipated. That was a relatively quick demise. Some icebergs have been observed floating around for up to 18 years. Suppose they remain in the relatively cold waters. It all depends on where A76 decides to go. Satellites have helped scientists keep track of these monstrous movements, whereas they would go unnoticed in the past. That's how they know that by day 148, this iceberg had split into 3 fragments, imaginatively titled A76A, A76B, and A76C. The numbers might be boring, but they're based on the Antarctic quadrant in which they were first sighted. If these enormous chunks do break up entirely, it will not add to rising sea levels because it was already part of the floating ice shelf. Imagine these ice chunks in your glass. They already take up a certain amount of space. They will simply change form into water. Icebergs like this one are different from glaciers or ice sheets found on land. Those are the things that help to raise sea levels when they break off and melt. For example, if the whole of Antarctica's ice sheet were to melt, it could raise sea levels by nearly 190 feet. If you think A76 is enormous, and it clearly is, there was another that makes it look small in comparison. On record, the largest iceberg was sighted in November of 1956, 150 miles west of Scott Island in the South Pacific Ocean. Ironically, it was seen by a ship known as the USS Glacier. It was sized over 12,000 square miles. This iceberg was larger than the country of Belgium. What may happen to the chunks of A76 will depend on a few factors. Ocean currents can make a significant impact, and wind direction and speed can too. They may move closer to coastlines, where they can freeze into pack ice. They can also drift into shallow waters and hit the seabed, called seabed gouging. The deepest part of the iceberg can act like the keel of a boat. It digs into the ocean floor, but the sheer size of the iceberg keeps it moving. Soon it's tearing up the floor, creating a long, narrow furrow or a gouge. Fish would scatter, the earth would shake, the noise would be tremendous. It's actually quite common in offshore environments near where ice is found. You would not want to be scuba diving nearby when one of these rips through. However, it would make for a spectacular sight. Generally, icebergs deteriorate through melting and fracturing, which, as you can imagine, changes the mass and the surface area. Combined with wind and ocean currents, it can make iceberg modeling difficult. As for A76, we'll just have to wait and see. Before we go, let's return to our imaginary voyage down the English Channel. The island of ice, 73 times the size of Manhattan, with its gigantic frosty finger pointed down toward the Celtic Sea, rolling steadily onwards, unable to be stopped. Hundreds of thousands of people have flocked to the coasts of both England and France to watch this extraordinary spectacle as it cruises by. On top of the ice, there are thousands of penguins playing happily. They almost look to be waving back to the abundance of sightseers who cheer them on their way, the children jumping with joy at the most spectacular sight they've ever witnessed.
There's a stretch of water that even the most experienced explorers fear. No matter what season you choose to cross it in, you risk meeting face-to-face with waves that can reach as tall as the Hollywood sign. I'm talking about the Drake Passage, the waterway connecting the Pacific Ocean to the Atlantic Ocean, stretching from Cape Horn at South America's southernmost tip to Antarctica's South Shetland Islands. It's about as wide as the distance from London to Berlin and takes up to 48 hours to cross. Some sailors compare getting on the other side to going to the moon. That's how challenging it is. Even the man who discovered it, Sir Francis Drake, never sailed these waters because they seemed too dangerous to him and opted for a calmer, although longer, Strait of Magellan. The passage took the lives of around 20,000 sailors and over 800 ships. Tourists who want to see Antarctica cross the Drake Passage on a regular basis, although it's still often called the world's most terrifying ocean crossing. The Antarctic Peninsula, where travelers go, isn't really part of Antarctica itself. It sticks out and points towards South America like two fingers almost touching it. The water gets squeezed between these two land masses, making strong ocean currents. The passage is part of the Antarctic Circumpolar Current, the largest ocean current on Earth. The water rushes through the passage at a speed between 95 and 150 million cubic meters per second, which makes it rougher. And then there are winds that usually blow from west to east and are very strong between 40 and 60 degrees latitude. That's why those areas are called the Roaring Forties, Furious 50s, and Screaming 60s. Land slows down winds, which is why storms hitting Ireland and the UK get weaker as they move east. But Drake's latitude is the only place where winds can blow all around the Earth without being stopped by land, so they keep getting faster. These strong winds turn into huge waves that can hit ships really hard, normally around 13 to 16 feet tall. They're much higher than waves in the Atlantic. Drake Passage also has underwater mountains that you can't see. The huge current squeezes through this narrow passage and causes waves to crash against these mountains underwater. These internal waves create whirls that bring cold water up from the deep ocean. So it's not just rough on the surface, the water is wild all the way down. The first sailor managed to sail around Cape Horn and through the Drake Passage in 1616. It was a Dutch navigator, Willem Schouten, in 1616. But the most famous attempt to cross it was undertaken by Sir Ernest Henry Shackleton on his ship named Endurance. He and 27 of his men set off from South Georgia, aiming to reach Vassal Bay in Antarctica. But things didn't go as planned. On January 19, 1915, their ship got stuck in the ice. And by October, it began to sink. They camped on floating ice for 2 months before sailing lifeboats to a remote, icy place called Elephant Island. Shackleton and 5 men made a risky journey to South Georgia to get help. It took them 15 days to cross Drake Passage with hurricane winds. Finally, they arrived safely and organized a rescue for the rest of their crew. Scientists found the shipwreck of Endurance only in 2022, 10,000 feet below the water. In December of 2019, 6 fearless athletes decided to cross the Drake Passage by rowing a boat for the first time in history. It took them 12 days of non-stop rowing with a 90-minute rotation of rowers. They managed to do it, and it was probably the hardest possible way to cross the passage. The athletes mentioned it was cold, wet, and dirty, and the waves hit them like walls. The weather in the Drake Passage changes a lot, but ship captains can always see it coming and change their path. They will move the departure time to have a safety margin and not to get stuck in the middle of the passage in the worst possible conditions. Sometimes, the journey will be smooth and calm, and they call it Drake Lake. Other times, people on the ship will feel rough waves, which is called Drake Shake. Some experienced captains who often cross the passage say that the Drake Lake effect happens once in every 10 crossings, and they see the Drake Shake once or twice in every 10 journeys. A schooner or a kayak will probably not survive the journey among giant waves, but modest vessels and cruise ships have sturdy hulls and advanced stabilizing mechanisms. So, the journey isn't that dangerous anymore, but still, it's quite an adventure, especially if you're seasick. If you don't feel like risking it but want to travel from the Pacific Ocean to the Atlantic Ocean by water the fast way, the Panama Canal is waiting for you. People first started thinking about making a water path across Panama in the 16th century. Back then, a Spanish explorer found out that only a thin piece of land separated the two oceans. But it seemed impossible to build it because of the mountains and thick jungle, so the idea had to wait a couple of centuries. Finally, in 1880, France, led by the man who built the Suez Canal in Egypt, tried to make the canal. But the people who started the construction soon found out it was much harder than it looked on a map. The land in Panama was one of the toughest and most dangerous places to dig a big waterway. Workers had to literally move huge mountains in a jungle full of snakes, where it was really hot and rainy. During the wet season, heavy rain turned rivers into wild rapids and soaked the workers. Sometimes, they didn't see the sun for 2 weeks, and their clothes stayed wet all the time. Big rocks were falling and tiny mosquitoes that carried malaria made people very sick. And then, an earthquake happened on top of everything. They were losing thousands of people. That's why France decided to abandon the project after 7 years. Then, the United States bought the French assets in the canal zone and finished it by 1914. It cost the US around $375 million. The 50-mile-long passage of water saves ships traveling between New York and San Francisco 7,872 miles. Around 14,000 ships use it every year and pay around $1.8 million in tolls. So it looks like it all paid off. Another challenging waterway in this part of the world is the Amazon River. It's around 4,300 miles long and flows through 3 countries with over 30 million people living in its basin. But there isn't a single bridge across it. The river has many marshes and soft soils, so engineers would need to build very long bridges and very deep foundations, which costs a lot of money. Building bridges over deep water is tough, but in other places in the world, engineers can use things like floating platforms to help. The river's path and water levels change a lot during the year. During the dry season from June to November, the river is usually 2 to 6 miles wide. But in the wet season from December to April, the river can become as wide as 30 miles. And the water level can rise by 50 feet. That's why they can't build floating bridges or pontoons. The riverbanks are made of soft dirt that moves and erodes with the seasons, and it makes things even harder. It would have to be an absolutely unique project to overcome all these challenges. Luckily, there's no pressing need for a bridge across the Amazon right now. The river mostly goes through areas that are sparsely populated, so there aren't so many major roads to be connected by bridges. Look at those lush coniferous forests and tundra. What a wonderland! You may have mistakenly thought it's Canada, but it's not. It's Antarctica, about 34 million years ago. So what makes Antarctica this frigid today? It turns out a mix of dropping carbon dioxide levels and some tectonic shuffle played a huge role in transforming this ice-free paradise into the frozen continent we know now. About 50 million years ago, CO2 concentrations were sky high, strutting around at around 1,000 to 2,000 parts per million. But as those levels tumbled down, global temps started to drop, paving the way for the mighty ice sheets that later took over Antarctica. While the CO2 dive was happening, tectonic activity was also working its magic. The big split between South America and Antarctica opened up the Drake Passage, which created the Antarctic Circumpolar Current. This powerful current acted like a bouncer, keeping warm air and ocean currents from crashing the Antarctic party, and helping keep things rather frosty. If you mix up Australia and Antarctica, you're not that wrong. These 2 continents used to be one. If you mix up Austria and Australia, it's much worse. By the way, don't fall for the internet myths and memes. There's no help desk in Austria specifically for people who intended to fly to Australia. Now, look at this magnificent Australian pink beach. It's precious, and not in a figurative sense. Those mysterious pinkish sands are actually garnet, and it's widely used in jewelry. Geologists studied those sands and came to the conclusion that the garnet contained there is older than local mountains. That doesn't make sense, right? In fact, it does. You see, Australia didn't used to be this very detached continent as it is now. Many millions of years ago, Australia and Antarctica were part of the supercontinent Gondwana, and glacial erosion released the garnet, which eventually made its way to the beach. These sands formed when South Australia was flat and chill, long before the mountains appeared. Most garnet gets washed away, but this batch has a rich history, tracing back to glacial rocks in the Transantarctic Mountains. So this pink sand comes from an ancient mountain range hidden under Antarctic ice. Not only does Antarctica ice hide gems like garnet, if you look harder, you might find entire buildings. Sounds insane, but this is exactly what a British explorer did. His name is Chris Brown, and he uncovered an entire building beneath the ice. He was traveling to the pole of inaccessibility, And it all started with a bummer. Chris and his son had their plane broken. Suddenly, they spotted a lone bust peeking out of the snow. This place was an old meteorological station. Despite freezing conditions, Chris and his son Micah had a blast exploring. Chris is on a mission to conquer all 7 earthbound poles of inaccessibility and has tackled 5 so far. I guess you already know that Antarctica is the largest desert on Earth, much larger than the Sahara or the Gobi. Still, despite being the driest continent on Earth, it boasts a seriously weird waterfall. Nestled in the mesmerizing McMurdo Dry Valleys, it's 5 stories tall and looks like it's gushing blood. It's even called Blood Falls. It may look outlandish and even frightening, but its nature can be easily explained. The water that creates this crimson cascade was once a salty lake, but over time, it became sealed off from the outside world when glaciers formed on top of it. Now, this ancient water hanging out 1,300 feet below the surface has cranked up its salt levels to 3 times saltier than the ocean. This salt water is also loaded with iron and gets 0 oxygen or sunlight. When the iron-rich water trickles through a crack in the glacier and meets the air, it rusts up, turning dark red. You may have mistakenly heard that no bug species belongs to Antarctica, but it's not exactly true, because there's this tiny Antarctic midge living there. Plus, there are some spiders too. Those aren't your average spiders hanging out in the darkest corners of your apartment. Those are critters lurking in the chilly darkness of the Antarctic ocean floor. These little marine creepers are actually arthropods and can stretch around 20 inches across. As if that wasn't bizarre enough, they also breathe through little holes in their legs. Quick question. What's the color that you associate most with Antarctica? I'm sure it's white. That's my association too. However, Antarctica may look like a slice of watermelon. That colorful snow comes courtesy of a tough little algae called Chlamydomonas nivalis. When things start to warm up during the Antarctic summer, these little guys release their vibrant red and green spores, painting the snow in wild and funky colors. But it's best to steer clear because that snow is not just a pretty sight. It's also toxic and definitely not edible. Searching for fossils is always a blast, but when you're in one of the most remote spots on the planet, it gets even more exciting. A diverse team of scientists recently hit the mother lode, pulling in over a ton of fossils from ancient marine life, dinosaurs, and birds from the late Cretaceous period, about 71 million years ago. Their adventure kicked off with a flight to South America, followed by a 5-day trek through the infamous Drake Passage. Upon reaching Antarctica, they set up camp using helicopters and inflatable boats. You might be thinking, why dig in Antarctica with all that ice? Well, it turns out there are places where rocks pop up, depending on the season. The team went to James Ross Island, located in the Antarctic Peninsula, and they went there during February and March. And that's one of the few parts of Antarctica where in summer, rocks are exposed, and those rocks can come from the age of dinosaurs. The expedition was a success, as they discovered over a ton of remarkable finds. Next up, the fossils will head to Chile before making their way to Pittsburgh's Carnegie Museum of Natural History. Among their discoveries, they found relics dating back about 71 million years, alongside some around 67 million years old, including plenty of snails, clams, and various marine creatures. Yikes! Look at this creepy sea worm. It could live in LA and be a star in a horror movie, but it chooses to call the chilly waters of the Southern Ocean near Antarctica its home. These worms can grow up to 8 inches long and 4 inches wide, but don't let their spooky exterior trick you. Research suggests they might actually be superheroes in disguise, playing a vital role in keeping ecosystems buzzing. Now, see that head? It's not really a head, it's just a retractable throat that helps this toothy creature chow down on its meals. Antarctica has many creepy critters to offer. Let me introduce you to the Antarctic strawberry feather star. It's not like Patrick from SpongeBob though. It's more like a deep-sea creature straight out of a horror movie. Picture this: 20 wiggly arms, some stretching up to 8 inches, all decked out with these bizarre little bumps. Yikes indeed. Back in 2014, scientists buried 34 seismic monitors in the snow on the Ross Ice Shelf, which is huge. Think of it as an ice slab the size of Texas, just chilling over the Southern Ocean. These clever little machines picked up a nearly non-stop buzzing. Even though our human ears usually can't catch these low-frequency sounds, scientists have worked their magic and made them audible for us. They even shared the creepy audio online. A glaciologist from the University of Chicago says that if you could hear this vibration, it'd sound like a swarm of cicadas taking over the backyard in late summer. But these glacier explorers weren't trying to capture spooky tunes. They're actually on a mission to monitor the Ross Ice Shelf because things are heating up, literally, and the ice is melting faster than ice cream on a hot day. Ice shelves are like Earth's safety plugs, keeping all that massive ice from surging into the ocean. So what exactly is making all that noise? It's likely just strong winds whipping across ice dunes, creating a kind of natural vibration.
So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas fault line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas fault line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tejon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something it can cause more damage than the Big One. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put 2 and 2 together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed. But Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe.
These dark patches on Greenland's ice sheet aren't just any old stains. Every summer, the ice, which is usually bright white, turns murky gray in certain areas. This so-called dark zone was a huge mystery for a long time, until some studies discovered that this weird transformation was connected to the odd appearance of red, green, and brown-colored algae. The scariest part is that this algae bloom keeps growing. The dark zone is getting darker, and terrifying microbes might start appearing. Now, the rest of the world should be concerned. The Greenland ice sheet is like a massive ice blanket that covers around 80% of the island. It's so thick that it holds about 8% of the world's freshwater ice. For most of the year, the ice looks like a giant untouched white sheet stretching over the land. But when summer rolls around and temperatures start to rise, things begin to change. The ice melts, revealing rocky areas along the coast. And as you move further inland, that once smooth white ice becomes darker. This is the dark zone, and it covers an area of around 248 miles in length and 62 miles at its widest point. This weird phenomenon happens basically for two reasons. The first one is black carbon. Just like dust that builds up on your bookshelf, the ice in Greenland has the same issue. The wind carries a mix of dust and soot to this icy area. But unlike your bookshelf, you can't just wipe it off with a cloth. In Greenland's case, this dirty mix settles on the ice and sticks around for thousands of years. So, the dark zone is basically covered in a fine layer of dust that's built up over time. Back in 2014, researchers analyzed this dirty mix and found that the darker ice areas were filled with black carbon. This black carbon didn't just appear out of thin air. Well, actually, it sorta did. Scientists believe it mostly comes from smoke produced by wildfires in northern Canada and Alaska somewhere in the past. As you might guess, black carbon is black, which is why it makes the ice look darker. Now, the second big reason for the Greenland ice sheet's summer makeover has to do with those algae we mentioned earlier. We're mostly talking about two types of it, the Ancylonema alaskana and the Ancylonema nordenskjoldii. Both of them love cold water regions. During winter, they stay in a dormant state deep within the ice. But when spring comes, they start to slowly migrate to the surface. By the time summer hits, they're ready to bloom and soak up nearly 24 hours of sunlight each day for photosynthesis and growth. Normally, these algae are green, but when exposed to sunlight, they turn brown as a natural way to protect themselves from harmful ultraviolet rays. And this color change is also what makes the ice in Greenland look darker. So far, this has been normal behavior. What's really alarming is that these algae blooms are getting bigger and bigger every year. This happens because they thrive on phosphorus, a nutrient that's plentiful out there and comes from a mineral called hydroxylapatite. This mineral is found in a type of rock that breaks down into tiny dust particles, which are then blown across the ice by the wind. As the climate gets warmer, the rocks dry out more, and stronger winds carry more dust. More dust means more phosphorus, leading to more algae growth. See? It is a cycle, and it keeps getting worse every year. Studying this is crucial to understanding why the dark zone keeps getting bigger. From the year 2000 to 2012, its size increased by 12%. But you might be wondering, why should we care? After all, it's just ice getting darker, right? Well, not exactly. Think about how you can't stand wearing black clothes on a hot, sunny day. They soak up the heat and make you feel even hotter. That's because darker surfaces absorb more sunlight. The same thing happens to ice. Together, dust, black carbon, and algae blooms are responsible for about 70% of the variability in albedo on the Greenland ice sheet. Albedo is just a fancy word for how reflective a surface is. If you take two surfaces, one white and shiny and the other dark and rough, the white one will reflect a lot of light and heat, giving it a high albedo. The dark one, on the other hand, will absorb more light and heat, so it has a low albedo. During the summer, the Greenland ice sheet experiences a reduction in albedo. This means the ice absorbs more sunlight, and when ice absorbs more sunlight, it melts faster than it should. This is why understanding what's happening in the dark zone is so important. It helps predict how quickly the Greenland ice sheet is melting and how it can affect the rest of the world. Greenland's ice sheet is the second largest in the world, covering an area about the size of all the land in the United States east of the Mississippi River. And its huge mass of ice averages a thickness of 1.4 miles. Unfortunately, the ice loss has skyrocketed. Back in the 1990s, Greenland was losing about 25 billion tons of ice per year. Now, it's losing around 234 billion tons per year. That's nearly 10 times more ice melting away each year. According to NASA, if all of Greenland's ice sheet were to melt, it would increase global sea levels by about 24 feet. That could be catastrophic for coastal countries and cities around the world. The Netherlands could be submerged, the Bahamas could be almost completely wiped out, and many of the Philippines Islands would be at risk of disappearing. All of this may seem like a distant reality, and it is true that most scientists believe it would take several hundred or even thousands of years for the ice sheet to melt completely. But it is important to know that Greenland didn't always have this thick layer of ice. Very recently, researchers took a close look at some sediment from the bottom of a 2-mile-deep ice core extracted from the center of Greenland. They found that the soil had traces of willow wood, insect parts, fungi, and even poppy seeds. So these fossils are the first direct evidence that Greenland's ice sheet melted away in the recent geological past, around 400,000 years ago. At that time, Greenland was home to a green tundra landscape with insects and plants. This discovery is both fascinating and scary because it shows that the ice sheet collapsed before and might be more fragile than scientists originally thought. There is another concern too. A recent research collected meltwater from different spots on the Greenland ice sheet and found that the water samples were packed with hundreds and thousands of microbes. The concern is that they could be released into the ocean in the future. And some studies already suggest that areas near where a lot of glacial meltwater flows have a higher risk of viruses jumping to new hosts, like from animals to humans. Even though experts believe the chance of a doomsday virus coming from the glaciers is very small, it's still not zero. The truth is, we don't know much about the thousands of microbial species living on the surface of the ice, and there is simply not enough data to fully understand how dangerous these organisms might be. All of this might sound concerning, but we shouldn't panic just yet. There's still a lot we don't understand about what is darkening the Greenland ice sheet. We still need more detailed measurements of the relative abundance of dust, algae, and black carbon, as well as a better understanding of how these potentially dangerous microbes could affect our lives. The more we learn, the better we can predict what's going to happen and how we can prepare for it.
A beam of electric light pierces the darkness over the calm waters of the Atlantic Ocean. The Titanic is quietly making its way through the waves, its passengers asleep, when suddenly a monstrous white shape is caught in the light beam. The fateful iceberg is about to rend the side of the legendary ship. April 14, 1912. Only 2 days before someone will take a photo of a giant iceberg with a pretty unusual elliptical shape. It turns out that this iceberg most likely formed out of snow that fell 100,000 years ago. Researchers used computer modeling to figure out its origin. They used data from 1912 and added some new information about winds and ocean currents. They concluded that the iceberg was probably a part of a small cluster of glaciers in southwest Greenland. These days, it's possible to calculate the routes of such icebergs in any given year in the past. So the infamous chunk of ice was on its way from Greenland to an area further south from Cornwall. If the ship had passed through that region only 2 days later, the iceberg would have moved far away from the point where they met. At first, The weight of the most well-known iceberg in the world was 75 million tons. With time, it started to slowly melt away. And when it sank the Titanic, its weight was only 1.5 million tons. By the time of the collision, it had probably been melting for months, but it was still a true monster. When the Titanic sank, the iceberg was 400 feet long, and more than 100 feet of its surface was above the water. Some people believe it was a supermoon that caused the Titanic to sink. That night, there was a rare lunar event. It hadn't happened for 1,400 years. In normal conditions, the iceberg wouldn't have traveled so far south without melting and losing the largest part of its mass. But the supermoon could have been the reason for an unusually high tide that pulled the iceberg away from the glacier way faster than usual. There's a specific type of bacteria that slowly consumes the remains of the Titanic. Salt corrosion, ocean currents, freezing temperatures, plus this rust-eating microorganism might consume the entire wreckage. American actress Dorothy Gibson was aboard the Titanic. She survived, and when she arrived in New York, she started filming a movie called Saved from the Titanic almost right away. The movie was released only a month after the Titanic sank, and in the movie, she even wore the same shoes and clothes she had during the actual disaster. The movie was a big success at that time, but the only known copy was destroyed in a fire. 14 years before the Titanic sank, a novella called Futility had been published, and it seemed to have predicted the whole event. The plot centered around a fictional ship called the Titan that sank during its voyage. The Titan was almost the same size as Titanic, and they both went to the bottom in April. The reason was hitting an iceberg, too. Both the real and fictional ships were described as unsinkable, and both of them had the legally required number of lifeboats, which, as it turned out later, were nowhere near enough. We've seen it in the movie, but there were some real-life love stories happening on the Titanic, too. 13 couples even took a trip on the Titanic as part of their honeymoon. One of the couples owned Macy's department store in New York. Once it became clear the Titanic was rapidly sinking, the woman refused to go into a lifeboat without her husband. But he didn't want to join her while there were still women and children who he thought had to go first. Then his wife gave her coat to her maid. She insisted that the maid should get into the lifeboat, and she wanted her to be warm. As for the woman herself, she decided to stay with her husband till the end. Some people believe Titanic sank because of a mummy, not an iceberg. It all started around 1000 BCE with a mysterious woman who lived in Egypt, in the city of Thebes. People knew little about her, but they called her a priestess. Her mummy was put in a wooden sarcophagus and covered with a large lid with the image of her face and some mystical inscriptions. This place had been hidden until the first half of the 19th century, when a group of locals accidentally came across it. They disturbed her peace. No one knows how, but the mummy disappeared that day without a trace. A couple of decades later, a group of rich friends from England traveled to Egypt and found the empty mummy casket with the image of the priestess, whose dark eyes seemed to be looking into the void. They decided to buy it, but the buyer disappeared the same night before he even got the case. All members of the group had some accidents. The casket changed its location a couple of times until it, as some believe, ended up on the Titanic. It took more than 70 years for a robot submarine to find the ruins of this legendary ship. The wreck lies nearly 13,000 feet under the surface of the Atlantic Ocean, split into two halves. Why did the liner break apart? No one knows exactly. Some think it happened because of the water that got inside when the ship collided with the iceberg. The pressure was so powerful it separated two parts of the vessel, starting with the ship's bottom structure. Others say it was because of the hull rivets. They had a high concentration of slag or smelting residue, and that's something that can cause the metal to split apart. The ship generally had many flaws, starting with the design. The watertight bulkheads weren't completely sealed on top. This allowed the water to flow between the compartments and, in the end, sink the vessel. The iron of the ship's rivets and steel of the hull ended up ruined because of high sulfur content, cold temperatures, and high speeds. The steel shattered and the rivets popped out quite easily. Because of this, Titanic sank 24 times faster than it would have otherwise. If the ship had hit the iceberg head-on instead of ramming it with its side, it would have probably stayed afloat. How come the crew members didn't have binoculars? It would have surely helped them spot the iceberg on time and maybe even avoid the disaster. But the binoculars on the Titanic were locked in a storage cabinet. Only one crew member had the key, and he had been transferred off the ship right before it set sail. He later said he hadn't remembered to hand over the key. But even without the binoculars, the ship might have had some time to change course and avoid the collision if the crew had gotten some warning. But that's the thing, someone did warn them. About an hour before the incident, a ship that was relatively close to Titanic, the SS Californian, sent a message to inform them it had stopped because of dense ice field. But the warning never got to the Titanic's captain. Some experts say it was because the radio operator didn't think it was that urgent. And later, the SS Californian said they didn't get a call for help from the Titanic because their radio operator was off duty. Some say the crew on the Titanic couldn't spot the iceberg on time because of an optical illusion. Atmospheric conditions that night probably caused super refraction, which could have camouflaged the berg. After all, no one actually saw the iceberg until it was too close to the ship to somehow avoid the crash. Not even a whole minute passed between the moment they saw the iceberg and the collision. It was only 37 seconds, and it took Titanic 2 hours and 40 minutes to disappear below the ocean's waves. So, in the end, will the sun be to blame for destroying our planet? Or how about a huge meteorite? Or some kind of disease? Probably not. It seems that life will disappear for a very unexpected reason. Humans, animals, insects, fish, and most microbes will be wiped off the face of the Earth because of oxygen, or more precisely, because of its absence. Recent research has shown that the number of freshwater reservoirs with very low or no oxygen levels in coastal areas is increasing worldwide. Over the past 65 years, 4 times more oxygen-deficient waters have appeared in the world's oceans. What does it all mean? It's likely that life on Earth will vanish much sooner than the sun's energies dries up all the oceans. The end is likely to come in a little more than 1 billion years. But this doesn't mean that the planet will disappear too. The period when Earth is filled with oxygen will make up just about 20 to 30% of the total lifespan of the planet. So we're just temporary guests here. Just think how long that is, 1 billion years. The first Homo sapiens appeared only about 300,000 years ago. That is, the entire history of humanity occupies less than 500,000 years. So relax. 1 billion years won't pass very fast. By that time, humans won't be on Earth anymore. We might master space travel and find a new planet in the vast depths of space. But why can we lose air? As the sun heats up, the planet gets warmer and warmer, and this heat breaks down carbon dioxide, the gas which is necessary for all plants to photosynthesize. Without carbon dioxide, they can't produce oxygen. With a drop in carbon dioxide levels, the methane content will increase, and this gas is quite harmful to us. Now, this all sounds logical, but this is a secondary reason for the lack of oxygen. The real problem is something else entirely. As the sun becomes brighter, it will begin to heat rocks on Earth, such as granite and basalt. These rocks will start to break down faster. When they collapse, they take carbon dioxide from the air, which warms our planet. If there's less carbon dioxide in the air, Earth should become colder. But there's a problem. The sun will shine more, and its heat will outweigh this cooling effect. So even if rocks take away carbon dioxide, the sun will blaze so much that Earth will still become extremely hot. Next, when the sun shines more intensely, it, along with other natural factors, contributes to the breakdown of granite and basalt. These rocks mix with carbon dioxide and water to make carbonates, which go deep into the earth. This takes carbon dioxide out of the air, which means plants can't make as much oxygen because they need carbon dioxide to do that. Besides, volcanoes release gases, which also reduce the amount of oxygen in the air. So the sun, by destroying rocks, affects what happens inside Earth and controls how much oxygen there will be in the air. In about 1 billion years, the sun will become so bright that no rocks will be able to save Earth from its heat, and the escaping gases will halt photosynthesis and oxygen production. And then, our planet will return to the state it was in about 2.4 billion years ago, to the time when the Great Oxidation Event began. And this event was much more important than, say, the first Olympic Games or the appearance of humans on the planet. Billions of years ago, there was almost no oxygen on Earth. Instead, there was a soup of gases, such as nitrogen, ammonia, methane, carbon dioxide, and others. Yes, we have these gases in the atmosphere today, but there used to be a lot more of them in the past. It was difficult for any form of life to originate in such conditions. But after some struggle, it succeeded. At first, Earth was inhabited by the simplest bacteria, including cyanobacteria. They learned how to make oxygen using sunlight, water, and carbon dioxide. These bacteria worked for millions and billions of years and made so much oxygen that it began to accumulate in the air. This was what we now call the Great Oxidation Event. It was like a great celebration of life, because with oxygen, new living beings could appear. But by the way, cyanobacteria didn't learn photosynthesis because they were like, oh, let's make oxygen, it's so cool. No, oxygen was just a byproduct. Cyanobacteria wanted only one thing, to get as much energy as possible. And for this, they learned photosynthesis. It helped them store energy using sunlight. They used special pigments to absorb light, and the result of this process was the release of oxygen. This had been going on for hundreds of millions of years, and then, at some point, they made too much oxygen. This oxygen started to spoil other gases that had been there before. For example, it ate a lot of methane. Because of this, Earth cooled down a bit, and the Ice Age began. But that's another story. In short, in 1 billion years, we risk going back to that difficult time. But let's hope that we'll manage to move to another planet on our spaceships or come up with some other solution. And what'll happen to our home planet next? Will new life be able to originate there without so much oxygen? Well, it's possible, but it'll be much more difficult. This will require another source of energy besides the sun. It can be, for example, hydrothermal vents. And by the way, there are ecosystems on Earth that use this type of energy. You can find one of them in the Mobile Cave in Romania. Imagine a place where there's little oxygen. It's dark. The sun's rays don't reach there. Over millions of years of evolution, a unique and slightly creepy life has developed in this cave. It was first discovered in 1986, and scientists are still exploring this place. The entrance to the cave is just a small hole in the ground. A narrow tunnel goes deep underground. Inside the cave, the air is filled with hydrogen sulfide and carbon dioxide, and there's half as much oxygen there as on the surface. A human can't stay there without a special mask. But for local forms of life, this is home, and they feel great there. There are several dozen species living in the cave, and many of them aren't found anywhere else on Earth. Here you can see strange little monsters, white snails, white spiders, centipedes with long whiskers, transparent shrimp, and even unknown species of leeches. Since there's no light in the cave, all these creatures don't need eyes. They're blind, but they have long sensitive antennae and paws that allows them to navigate in the space. They also have no colored pigment, so all these bugs and spiders are either white or transparent. But if there's so little oxygen there and nobody does photosynthesis, then how does all this life survive? It's all thanks to the unique bacteria autotrophs. They absorb carbon dioxide and produce nutrients. These bacteria are food for other organisms, and those, in turn, become food for larger creatures. So a whole food chain has been built in the cave, which provides all the inhabitants with food. Evolution has created a unique ecosystem that exists separately from the rest of the world, It's like a small universe that has developed according to its own rules. However, this universe is not expanding, because all living beings here can't live away from hydrothermal vents and autotrophs. Otherwise, where would they get their energy from? But let's imagine that the sun cools down, almost all the oxygen disappears, and the entire planet gets covered with hydrothermal vents. It's dark, and the air is filled with methane, CO2, and other substances, and somehow life begins. Even people appear at one point. What would they look like? Pale, thin, and blind creatures with very long arms that help them navigate in space. They have pets, large centipedes or cockroaches that move silently on the ground. People are also quiet because they don't have lungs filled with air to scream. There's silence in the world. People communicate through touch. No one travels. Everyone lives separately next to their hydrothermal source. The whole world has turned into a horror movie in 1 billion years.
We've all dreamed of visiting the Arctic and witnessing the natural wonders of polar bears frolicking on ice floes or the aurora borealis dancing across the sky. Well, sorry to break it to you, but you won't find any tourists flocking to Antarctica anytime soon. Why, you may ask? Let's dive into it. First off, where is Antarctica? It's located in the southern hemisphere, specifically at the South Pole. The Southern Ocean surrounds it, and most of the continent is covered by ice, making it one of the most remote and frigid places on Earth. Now, have you ever met someone who's visited Antarctica? Probably not. It's one of the least visited places on the planet, and only a handful of lucky explorers have seen its interior, which is mostly made up of glaciers and ice fields. But trust me when I say the wildlife and scenery are out of this world. Why shouldn't you travel to Antarctica? Well, for starters, the environment is incredibly fragile and can be easily damaged. Plus, there are no native human populations on the continent, so your travels would essentially be like visiting an uninhabited island. And let's not forget that it's also one of the most expensive destinations to travel to. Despite all that, Antarctica is not exactly guarded like a fortress, but there is an international agreement called the Antarctic Treaty. This treaty was negotiated to prevent any unwanted activity on the continent and bans some forms of testing done there by member states. But the primary reason we can't just waltz into Antarctica is that it has a delicate ecosystem that needs protection. The treaty states that Antarctica should be used for peaceful purposes only and should be free from any human activity that could harm the environment. Scientists are still learning about the continent's unique ecosystem, and our activity and machines could disrupt the delicate balance that exists there. If you're still itching to go to Antarctica, getting permission isn't exactly a walk in the park. U.S. citizens, for example, need to complete a special form and send it to the Office of Ocean and Polar Affairs. And once you're there, you'll need to follow some strict guidelines to protect the environment, like not disturbing any wildlife or taking souvenirs like rocks, plants, or animals. Now, technically, can you live in Antarctica? While there are no laws banning people from living there permanently, it's a very inhospitable environment and unsuitable for human habitation. Temperatures can reach -76 degrees Fahrenheit and below, making it nearly impossible for anyone to survive without the proper equipment and experience. Plus, the nearest piece of land is over 1,000 miles away, making any inhabitants completely cut off from the rest of the world. Who knows? Maybe one day we'll get the chance to visit this unique and fascinating continent. But until then, let's admire it from afar. Let's now talk a bit about the discovery of Antarctica. Unlike other places that were already inhabited, Antarctica never had a native human population. Ancient Greek philosophers had an idea about the continent and called it Antarctos, meaning opposite the bear. The bears it refers to are not the polar ones though, but rather the Great and Little Bear constellations, which are only observable in the northern hemisphere. As a result, the term signifies the opposite of the land of the bear. Whaling and sealing voyages in the late 1700s and early 1800s would venture further south when rounding Cape Horn at the tip of South America. It was known that going further south often meant stronger winds, but also the risk of hitting floating ice of all sizes and of winds and seas that could prove dangerous to the ship and crew. Captain James Cook was the first to cross the Antarctic Circle on January 17, 1773, in the Ross Sea region. He reached a point further north a year later, and though he didn't sight land, he came to within 50 miles and saw deposits of rock held in icebergs, indicating that a more southerly land existed. The first sighting of Antarctica is widely acknowledged to have taken place in January of 1820, during the voyage of two ships under the command of Captain Fabian Gottlieb von Bellingshausen, as part of a 2-year exploratory expedition around the world to discover new lands. The captain's ships were the first to have crossed the Antarctic Circle since Cook. The first undisputed landing on Antarctica didn't happen until much later, on January 24, 1895, at Cape Adare during the whaling voyage of the ship Antarctic, led by Henrik Bull. A small boat with 6 or possibly 7 men on board rowed ashore during calm conditions. You might not believe it, but Antarctica is actually a desert. With all that ice, you'd think it'd be like a winter wonderland with snowball fights and hot cocoa all day long. When we think of deserts, we picture camels and cacti and people struggling to find water. But in Antarctica, it's a whole different story. The struggle isn't to find water, it's to find anything that's not covered in ice. And the average rainfall has been just over 0.4 inches in the past 30 years. That's like a few drops of rain compared to what we're used to. So technically, it's not the dunes or sizzling heat that makes a desert, well, a desert. It's the lack of precipitation. But don't worry, if you ever find yourself lost in Antarctica, you won't have to worry about getting thirsty. Just make sure you bring a jacket and some mittens, because it's cold enough to make you into a popsicle. Not only is Antarctica one of the driest places on Earth, but it's also the coldest, the windiest, and the highest. Talk about overachieving. The penguins and scientists down in Antarctica have at times found themselves in a bit of a pickle when it comes to time. You see, unlike the rest of us on this big blue planet, there is no Antarctica time zone. All the lines of longitude meet at a single point at the South Pole, making it a bit of a head-scratcher when trying to figure out what time it is. Now, you might be thinking, but how do the scientists and researchers keep track of time down there? Good question. They typically stick to the time zone of the country they departed from. However, with stations from all over the world on the Antarctic Peninsula, things can get a little wacky. Imagine trying to coordinate with your neighboring countries without accidentally waking them up in the middle of the night. You might think that not much could survive in a place where the temperature is extremely cold, the sun barely shows up, and the wind could blow you away faster than a tumbleweed. Well, as in many places on Earth, life found a way in Antarctica too. Believe it or not, this frozen continent is buzzing with activity. It's home to billions of krill, which in turn attract lots of seals and more penguins than you can shake a fish at. But don't let their cute and cuddly appearance fool you. Penguins are the ultimate swimmers, with streamlined bodies that would make Olympic medal winners jealous. They come ashore to breed and chill, but their real talent is stealing pebbles from each other and forming mathematically precise huddles to stay warm. Antarctica is also home to the largest species of penguin on Earth. It's called the emperor penguin. Sure, these creatures are flightless birds, but that doesn't mean they can't jump. In fact, some of them can leap up to 120 inches. And let's not forget about the seals. With their furry bodies and special songs, these marine mammals are protected by the Antarctic Treaty, and they're thriving in the cool waters of the Southern Ocean too. But the real stars of the show are the whales. During the Antarctic summer, these huge creatures show up in droves to chow down on the abundant krill. It's indeed like a whale buffet down there.
How do you prepare for a long trip? You probably look up the route on Google Maps or watch a walkthrough on YouTube. Or maybe you ask someone who's been there recently. But what if you're bound for a place humans have never existed? Yes, I'm talking about our next-door neighbor, the Red Planet. NASA is planning a mission to Mars in the late 2030s or early 2040s. That's too far in the future, so why start preparing now? Well, it's closer than you think. Rookie astronauts spend at least 2 years training just to go out in space. For every hour they spend in space, they need to spend 10 hours underwater on Earth. This training only applies to spacewalks and the International Space Station. So far, some 600 people have been to space, but humans have never set foot on Mars. Traveling to this planet will require a different kind of training. Is there a region of Earth that closely resembles Mars? The Apollo mission's astronauts trained in Nevada. This is where Neil Armstrong and his fellow astronauts got a sense of what the surface of the moon would feel like. But Mars is different from the moon. It has gravity and an atmosphere. In this aspect, it resembles our own planet. Just one country, to be more precise: Iceland. NASA used this island in the far north of Europe as a testing ground for its 2020 Mars mission. And no, the mission didn't involve humans landing on the Red Planet. Just a small rover looking for signs of life. But the high-tech robot still needs some practice. Let's do a little test of our own. Compare the landscapes on Mars and Iceland. Are you struggling to spot the difference? Good. That means that scientists have picked the ideal training grounds for the upcoming Mars mission. An area entirely barren and devoid of life. That's how one researcher involved in the mission described Iceland. And this description perfectly matches the conditions future astronauts will encounter on Mars. But what's so special about Iceland? There are valleys that were created by volcanic eruptions. The island is still young in geological terms. Simply put, it's still forming. Lava flows, water, volcanoes, raging winds. Iceland has it all. The country's slogan is the land of fire and ice. The island's population is just above 350,000. For comparison, the city of Cleveland in Ohio has more residents than the entire country of Iceland. But the size doesn't always matter. Remember Euro 2016? When England lost to Iceland 2-1, their players became stars overnight, but Icelanders are closer to the stars than you think. The country has a space agency. Yeah, you heard it correctly. Now, this agency actually consists of 2 people who are trying to promote Iceland as a terrestrial analog to Mars. In short, this means that Iceland looks a lot like the Red Planet. The local duo wants to get space scientists to choose Iceland as a training ground for future astronauts. Their biggest argument is that it's cheaper. Sending people and equipment into space is expensive. Duh! According to Elon Musk, SpaceX launches cost around $2 million. That's way less than a typical NASA launch. A large portion of space research takes place back on Earth. Antarctica is ideal for studying cold and desolate places in outer space. Hawaii is perfect for exploring lava tubes and the composition of rocks. Just imagine the logistics behind going to both of these regions at the same time. This is where Iceland comes into play. It has diverse habitats that are relatively close to each other. So what exactly will future Mars-bound astronauts do in Iceland? To answer this question, let's travel back in time. Nevada wasn't the only place NASA's astronauts visited more than half a century ago. They prepared for walking on the surface of the moon in Iceland too. Their primary objective was collecting rock samples. These can mainly be found near volcanoes and lava fields, and Iceland has plenty of those. Around 60% of the local landscape is rocky and rugged. This makes the island the size of Kentucky feel like another planet. Add that to the fact that 80% of Iceland is uninhabited, and you get the perfect playground for astronauts. And there's another similarity with Mars. In summer, it can seem as if the sun never sets in Iceland. Locals go shopping at 3 a.m. In June, for example, the night can last only 2 hours. Sounds like a perfect open-air party destination. Well, not really. Who would want to party at a freezing temperature of 42 degrees Fahrenheit? That's the average low air temperature in June. Future astronauts spent weeks in Iceland, trying to adjust to these strange conditions. This helps them prepare for the long days on Mars. This is not a figure of speech, since days on the red planet are longer than the ones on Earth by 40 minutes. That's not much, considering the length of days on other planets. On Jupiter, a day is over in just under 10 hours, while a day on Venus equals 243 Earth days. But let's first land on Mars and then think of other planets, shall we? Have you been doing some math in your head? If one day on Mars is 40 minutes longer than on Earth, then how long is a Martian year? Nope, I'm willing to bet your calculations aren't correct. You forgot to factor in an important detail. The planet is farther from the Sun than Earth. This means that a year on Mars lasts 687 days, nearly twice as long as a year on Earth. Sorry, future astronauts, you'll get a birthday cake once every 2 years. There's another minus to the red planet, literally. The planet's average temperature is minus 76 degrees Fahrenheit. Makes Iceland's climate feel like the tropics, huh? Despite these extreme weather conditions, scientists believe that water once flowed on Mars. And where there's water, there's life. That's why NASA scientists lowered the tiny rover in the middle of a crater that they suspected was once a lake. This is where it stands the greatest chance of finding evidence of life. What about life forms on Mars? Looks like it's not science fiction. The planet has polar caps like Earth, and that's not all. Scientists believe they've even detected snowfall on Mars. Its atmosphere is 100 times thinner than that of our planet. It isn't a breath of fresh air, but it isn't extremely inhospitable like other planets. On Venus, it rains acid, and the temperature is high enough to melt lead. And on Jupiter, there are gigantic storms that rage on for centuries. Makes you fall in love with the blue planet all over again. Even Iceland sounds fun at this point. You might even want to learn Icelandic. If you're successful, then you can even read Old Norse, the language of the Vikings. And you'll know 100 words for wind. This will come in handy as wind speeds on the island can reach up to 40 miles per hour. Out in the open, you have to hold on to a fence or a signpost to stay on your feet. Iceland's climate will make you think twice before moving there. But for astronauts preparing for another world, this place is perfect. Iceland is equally impressive underground. In fact, the island might hold the key to sustaining human life on Mars. The surface of this planet is not very hospitable. The soil is poisonous and abrasive. It can easily cut through an astronaut's suit. But underneath the ground, the living conditions are more tolerable. And Iceland has a real-life model of this potential underground dwelling: lava tubes. Long tunnels carved out by lava making its way to the surface. These maze-like corridors are perfect human habitats. And they're cost-efficient. Nature had already built them for us. Future astronauts can walk through similar lava tubes in Iceland. Who knows? One day, their cautious steps might turn into giant leaps for mankind.
There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, The people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangaea. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangaea began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangaea's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, that piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, we can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place. It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zircon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research. But this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. And this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zircon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritia, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritia was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritia was covered in water when India broke away from Madagascar, something like 85 million years ago.
It happened in Iceland on Friday, March 19, 2021 at 8:45 p.m. About 20 miles southwest of the capital. Molten rock suddenly burst through the surface from below. Bright lava fountains then lit up the night sky. A volcano in this valley finally woke up after almost 800 years of sleeping soundly. We divide volcanoes into 3 categories: active, dormant, or extinct. Around 1,900 of them around the globe are considered active. That means they've erupted in the recent past and will likely do it again in the possible near future. Dormant volcanoes haven't popped off for a long time, but they still may in the future. You could say they're sort of sleeping. As for extinct ones, those guys haven't done anything in more than 1 million years. The eruption in Iceland wasn't super explosive, and this all happened 6 miles from the nearest town, so everyone was perfectly safe. Many even came to see it up close, while other brave visitors tried to fry eggs and bacon on the lava. Just be careful not to burn your breakfast black. Lava can be over 2,000 degrees Fahrenheit. It burns everything in its path. Yet it also produces some of the most fertile land for agriculture. This eruption gave a relatively small amount of lava at first, but it's been spreading across the valley in different directions, forming a sort of shield that's constantly growing. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can ooze slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous thing about volcanoes. That would be the toxic gases spewing from the eruption. And those spread faster and further than the lava flow. Luckily, in Iceland's case, the wind has been blowing these gases away from residential areas. Scientists weren't surprised this volcano erupted. They knew it was coming. Increasingly stronger earthquakes had been shaking this area for the past 15 months. There were 50,000 earthquakes within just the 3 weeks leading up to the eruption. That's 100 per hour. The volcano has been active since March, and geologists say this could last for weeks, months, years, or even decades of constant eruptions in the area. Mount Shasta is in the top 5 most dangerous volcanoes in the U.S., so geologists are keeping a close eye on it. The last eruption was in 1250. I wasn't around then, but this volcano erupts every 600 to 800 years. Which means, tick-tock, we're due any day now. About an hour from Portland, Oregon, there's an active volcano that last erupted in the 19th century. Next time it goes off, scientists think it'll produce larger amounts of ash and dust. This could cause an electrical blackout and make water unsafe to drink in the area. But the experts pay close attention to Mount Hood. They'll be able to give plenty of warning so people can react in time. Kilauea is one of the most active volcanoes in the world. It's been erupting almost constantly since 1983, making it also one of the longest eruptions known on Earth. It's the youngest land volcano in Hawaii. Volcanoes can take thousands of years to form, but others can pop up practically overnight. A volcano in Mexico just erupted in an open field in 1943 and started growing from there. Within a year, it was almost 1,500 feet tall. When the eruptions finally stopped 9 years later, the mount had reached a height of over 9,200 feet. Mount Fuji is an iconic symbol of Japan. The last time it erupted was in 1707, and it sent a shower of burning rocks as far as 60 miles away. If a similar eruption happened today, Tokyo would be within that vicinity. Mount Fuji is right on the Ring of Fire, that horseshoe-shaped region in the Pacific Ocean full of active volcanoes and earthquakes. From one end to the other, it's almost 25,000 miles long. It could wrap all the way around the Earth's equator. In January 2020, Taal volcano in the Philippines started spewing lava, sending huge plumes of ash half a mile up into the sky. The eruption even triggered a rare phenomenon, a dirty thunderstorm. That's when the smoke cloud above a volcano produces its own lightning. The chance of volcanic tsunamis was also high. Those are usually caused by tectonic movements that occur because of volcanic activity. Taal has erupted more than 30 times in the last 450 years. This volcano in Ecuador last erupted in 2016. Scientists think it might be showing some early warning signs of magma on the move. This is an active stratovolcano, a specific cone-shaped type with steep sides. They form from sticky lava that doesn't flow that easily. That lava goes around the vent, cooling and piling on itself to form these steep walls. These types are more likely to produce explosive eruptions like the ones we see in movies. Ruapehu is the oldest national park in New Zealand, a volcanic wonderland where you can closely see all those steaming craters, magnificent lakes, and unusual rock formations. It last erupted in 2007 and has had 10 eruptions since the mid-19th century. But eruptions, lava flows, and toxic gases aren't the only danger coming from volcanoes. There's also a thing called lahar, a kind of volcanic mud flow of debris. In between eruptions, snow melts and a lake forms in the caldera. If the last eruption brought mud, ash, and rocks in the lake, it becomes dangerously full. In that case, only a temporary dam holds it back. Indonesia has the biggest number of active volcanoes in the world, including one called Anak Krakatoa. It means child of Krakatoa, and its famous parent isn't far away. A huge tsunami in 2018 partially woke Junior, a scary thought since Senior had one of the most powerful eruptions ever seen on this planet in 1883. Krakatoa's boom was the loudest sound ever heard. People over 2,000 miles away could hear the explosion. The sound wave circled the globe 7 times, and scientists say it's hard to predict this volcano's eruption patterns. Mount Yasur in Vanuatu is one of just a few volcanoes in the world where you can see a lava lake. Tourists even go there to peer over the edge and get a look at the burning, bubbling lake below. Well, except for when the volcanic activity goes to levels 3 and 4 out of 5. That means there are more intense earthquakes, volcanic tremors, or steam, gas, or ash ejections. Then this place is off limits because, duh. This volcano in the DR Congo has the most active and largest lake volcano in the world. And all that lava is unusually fluid, meaning it travels faster and further than the stuff coming out of most volcanoes. It's certainly not amongst the tallest ones, but Ethiopia's Erta Ale is unique in that it has a lava lake almost constantly, which is pretty rare. The locals call it a smoking mountain because its lava lake often causes eruptions. This volcano is near the Danakil Depression, one of the hottest places on our planet. Merupi has been erupting on a regular basis since the mid-16th century. This volcano helps scientists do crucial research on how eruptions work and how they can warn people in time. After it was dormant for a while, this volcano in central Mexico sprang back to life in 1994. Ever since then, it's been producing huge mud flows and strong explosions in unpredictable intervals. In the past, enormous eruptions coming from this giant buried entire cities in pyramids. Imagine staying in a hotel, and waking up to the magnificent view of a massive volcano covered in glowing rivers of lava and clouds of ash. When it lets off heat, visitors to this area in Guatemala take a chance to roast some marshmallows there. One of the most active volcanoes on Earth is on a small island north of Sicily. Stromboli has regular explosions, together with glowing lava coming from vents inside the crater. Not too far away is Etna, Europe's most active volcano and one of the biggest continental ones in the world. By the way, Earth definitely isn't the only planet with volcanoes. The largest one in our solar system is on Mars. It would cover the entire state of Arizona, and it rises nearly 3 times higher than Mount Everest. Ooh, don't look down.
You're chilling in Hawaii, on the island of Oahu. A friend calls you up. Hey, I'm here too. Meet me in Maui. Great, but how do you get there? Your first thought is probably to take a ferry, but that's impossible. Hawaii is a pretty unique place. It's the most expensive state to live in. It has its own official language besides English. And it's the only American state made up entirely of islands. Hawaii has a total of 137 islands. 8 are the main ones, but only 6 are open to tourists. And the distance between those islands is probably bigger than you'd expect. For example, traveling from Oahu to the Big Island is around 185 miles, which is about the same distance as Chicago to Indianapolis. You might be surprised that you can't make that trip by boat. In fact, the only ferry system that actually takes passengers in Hawaii runs between Maui and Lanai. That's it. So your only option is to travel between islands is by plane. Honestly, it's a little surprising, especially considering how many people visit Hawaii every year. Tourism pretty much drives their economy, and in the first 8 months of 2024 alone, over 6 million people visited its beautiful beaches. Knowing that, we would expect Hawaii to set up a good ferry system to make it easier for visitors to get around. Just like in Greece. This would probably boost tourism even more, bringing more money to the state. But believe me, authorities and private companies also know that. In fact, they've already tried it. Ferries were a big way of getting around in Hawaii from the 19th century up until the 1950s. Since then, there have been a few attempts to bring back a ferry service, but unfortunately, they have all failed. One of the biggest attempts was the Hawaii Super Ferry, which aimed to provide a fast, affordable boat service between islands. It could carry almost 900 passengers and even allow them to bring their own cars along. The trial run started in 2007, and people were excited, but it turned into a big fiasco. A bunch of legal and environmental issues came up, like concerns about the impact on marine life, especially whales. The courts decided the ferry didn't go through the proper environmental reviews, and that caused a lot of trouble. By 2009, after tons of protests and setbacks, they had to shut it down. If a project like this comes up again, it will probably fail one more time. And there are a few reasons why it's almost impossible to set up a regular ferry system there. Let's start by talking about Hawaii's rough waters. They are deep and wild. Take the Alenoiaha Channel, for example. It's a 30-mile stretch that separates Maui from the Big Island. Its name means Great Billow Smashing Channel, and it lives up to that. It's over 6,000 feet deep, making it one of the most dangerous stretches of water on Earth. The wind there is also super strong, the fastest in Hawaii's coastal waters. But it's not any easier in the rest of the archipelago. The whole region gets hit by storms from the Pacific up north, sending big waves crashing into the islands and making the waters rough and unpredictable. Swells can come from 3, 4, or even more directions, making the sea feel really choppy. Someone who's not used to taking ferry boats would definitely find that, well, uncomfortable, to say the least. To deal with rough seas like this, the ferries have to be really big and strong. But that also makes them more expensive and harder to run than the ones in places like Alaska or Washington State. Another reason it's so tough to set up this system today has to do with marine life. A big ship moving through the shallower waters when docking could really damage the local ecosystem. And there's also the problem that the sea routes are also the migration paths of many sea animals, like humpback whales and spinner dolphins. Not to mention, ferry services can make it easier to spread harmful plants and animals, what experts call invasive species. See, Hawaii's ecosystem is super unique because it's been isolated out in the middle of the Pacific. When we talk about plants and animals that are native to Hawaii, we mean they got there on their own, no humans involved. They arrived with the help of waves, wind, or even birds flying over. But events like these are super rare, so for over 70 million years, their plants and animals didn't have to deal with outside competition. That's made them really fragile. So, when new species get brought in by us, it can be a big problem, and they could end up harming the environment. Hawaii's already been battling invasive species like fire ants, coqui frogs, and meconium, a fast-growing plant from South America that takes over native forests. People there worry that ferries, which carry cars and cargo between islands, could accidentally spread these invaders even more. Like we mentioned at the beginning of the video, the long distances between their lands don't really help either. For example, if you were to travel from Oahu to the big island of Hawaii by boat, it would take around 30 hours, and that's without any stops. The same trip by plane takes about 50 minutes. Ferries that cover long distances are much more expensive, so they need a much bigger demand to make them profitable. On top of that, the state doesn't really have the infrastructure, like enough ports and terminals to support the operations. So setting up new routes is pretty much out of the question. Airplanes, on the other hand, are a different story. The air travel industry in Hawaii is already well established and super competitive. That means flying is still the most practical option in Hawaii. Planes are quick, they don't make you seasick, and are pretty affordable, usually costing around $100 for a round trip. Okay, but what do the locals think about all this? Well, apparently, there isn't a huge demand for residents to commute between the islands all that often. Oahu is the busiest island in Hawaii, with about 70% of the state's population living there. It is where Honolulu, the capital, is located, and where most of the state's business happens. So, people from the other islands usually come over for a specific doctor's appointment or to catch a big concert. And that might happen once or twice a year, no more than that. So, even if people could choose between taking a ferry and a plane for these special occasions, most of them would probably still prefer flying. There are plenty of options between the main island airports. Planes usually start flying around 5 in the morning, and there are flights available every hour until the last one, which is usually at 9 in the evening. If you've been dreaming of going to this paradisiacal place but are worried about spending too much on plane tickets, I have some tips for you. First off, keep in mind that visiting all the main islands in 5 days or less is way too ambitious. So, if you don't have much time to spend there, think about your priorities. Each of the 6 islands open to tourists has its own vibe and activities. But you don't need to visit them all in one trip, and you can save some money by sticking to fewer islands. You can still explore the diversity of the islands by picking 2 that offer a nice contrast to each other. For example, while Oahu has that bustling city energy, Kauai has a much more relaxed vibe. Also, flights in the morning are usually cheaper, and it might be better to fly on a weekday rather than the weekend, although the price difference isn't usually huge. Hopefully these tips will save you some cash while still having an unforgettable island hopping adventure in Hawaii. Don't forget to share this video with a friend who's also dreaming of exploring these amazing islands.